Hey everyone, and welcome back. Before we begin, please make sure that you like and subscribe because it really does help out our channel, and it also really helps us reach other people in need of assistance with these topics. So in this video, we're going to be working with calculus, and we're going to be working on derivatives of these three equations shown here, or three expressions shown on screen here. So these three expressions, we are going to solve them using this formula, or this generic formula of d dx of an expression of ax to the power of b. And when you take the derivative of this ax to the power of b, it will turn into this, where we keep that a, there's our variable x, and then we have to the power of b, we are going to take that b, and then it drops in front of the equation, and then we subtract 1 from the power of b. So these three expressions, we're going to work with this type of formula here. And it does not really matter what the variable is. In this case, this one is x, but as you see in our first one, we are going to have u. You just replace x with u or any other variable that is shown in the expression. So number one, we have d du multiplied, or not multiplied, d du of 7 over u. So this is not really in this form just yet. So what we're going to have to do is we're going to have to turn it into this power formula here. So we're just going to rearrange this 7 over u portion, and we're going to rewrite it as 7u to the minus 1, because that's essentially what 1 over u is equal to, is u minus 1. So taking the derivative of this with respect to u, we're going to have our 7, which remains, it's our constant. And then we're going to have our variable u. We're going to take our power and we're going to drop it in front and multiply everything in the expression by that. So minus 1. And then our power will be the original power of minus 1 minus 1. So let's simplify this down a little bit here. So negative 1 times 7 gives me negative 7 u. And then minus 1 gives me minus 2. And you could leave this as your answer, or depending on how picky someone is grading this or looking at this, as if this is for your homework, you can rearrange it for minus 7 over u squared. Just like what we did here at the very beginning, just the reverse process of that. So either one of these two, minus 7u to the minus 2 or minus 7 over u squared, is the correct answer when you take the derivative of 7 over u. So that's our first one. Our second one is definitely not in the form of this power situation right off the start here, of d dx square root of 3x. So let's go ahead and let's rewrite this, and we're going to have to write this a little bit more than just once, just to get this portion of the square root of 3x into something that is similar to this. So let's go over here for a second. And the square root of 3x, well, anytime you have the square root of something, that is taking it to the half power. So we're kind of in that form just right now. But instead of it just being the variable x to the half power, the 3 is also to the half power. So we have to take this half power and throw it in here. And we can do this by this rule shown here, or I'm about to express, where we have a constant c times a variable x, and all that to the power of n. This is equal to that constant to that power times x to that power. So in this case, the c is the 3, x is the x, and the n is the 1/2. So let's go ahead and express it in this term over here. So we have 3 to the 1/2 power times x to the 1/2 power. Now we are in terms of this ax to the b. The only thing here is that the 3 to the 1/2 power is just square root of 3, and that'll be my constant a. And because 3 square rooted is not a very nice number, meaning it's not an easy number due to the decimal points here, we're just going to leave it as 3 to the half power. So of this equation up here, AXB, A is going to be 3 to the 1/2. Oh, let me write that a little bit better there. It's a little bit ugly. So 3 to the 1/2 power. And then x to the b will just be x to the 1/2, which is essentially just x squared rooted. So let's go ahead and rewrite the expression here of d dx of 3 to the 1/2 power times x to the 1/2 power. So 3 to the 1/2 power is my constant. Then I have my variable x of 1/2. We'll take that 1/2 and drop it in front. So multiply everything by that, and then subtract 1 from that power. So essentially what I have here is I have 3 to the 1/2 power divided by 2, because you're multiplying by a half, divided by 2, and then multiplied by x to the negative 1/2 power, because 1/2 minus 1 gives me negative a half. And once again, you could leave it like this if you wanted to, or what you could do is simplify things down a little bit further here, because 3 to the half power is square root of 3 over 2, and then x to the minus 1/2 power just means 1 over the square root of x. So you could just throw that x down there in the denominator, and you would end up with square root of 3 over 2 times x squared. Either one of those answers is acceptable for the derivative of square root 3x. All right, so we have one more to do, and that is the derivative of this whole expression of 6x cubed minus 12x. So we have d dx of 6x cubed minus 12x. So we have actually two portions here. We have the 6x cubed and the negative 12x. So depending on how many portions you have to split it up each time, because you're going to take the derivative of the first one and then add or subtract the derivative of the second one, depending upon this sign shown right here. So essentially, this expression is saying this. We're going to take the derivative of 6x cubed minus the derivative of 12x. So it doesn't matter how long the expression is. Anytime you have a plus or minus, you just do the derivative for each little portion inside there. So let's go ahead and do this. For the first one of d dx x cubed, or 6x cubed, the 6 is my constant. X to the power of 3, I'm going to drop that down in front, and then subtract 1 off that power of 3. Before we simplify this down a little bit further, let's do the second one of d dx 12x. So there's my minus sign, it stays there. 12 is my constant. Essentially, x showing no power is just x to the 1. And then when you drop that same power in front, you're multiplying by 1. And then you're going to subtract off 1. So what we have here is 6 times 3, which is 18, times x. And then 3 minus 1 gives me 2, minus off 12. And then x to the 1 minus 1 is x to the 0, which hopefully you know that x to the 0 is just 1. So in reality, we just have 18x squared minus 12. Anytime that you have, let me scroll up here. Anytime that you have, or when you're taking a derivative of an expression, and it is just a constant times x, and x has no power to it, that derivative is always just going to be the constant that is attached to that x. So as you saw here, we had d dx of 12x. So the derivative of that, you just drop the x because we're always lowering the power of x by 1. Well, essentially it's x to the 1. It'll go x to the 0, which is 1. So it just remains that constant there. So instead of writing out like this each time, whenever you see that expression, just drop it down and it will be that constant each time. So I hope this was helpful. And if you want to see more problems solved of this variety or this variations, please check out the other videos on our channel. Thank you for watching, and I hope you have a fantastic day.